Questions 11 through 20 on the 2009 Grade 10 Cayley Math Contest. Jillian has a collection of 50 songs that are each 3 minutes in length and 50 songs that are each 5 minutes in length. What is the maximum number of songs from her collection that she can play in 3 hours? 3 hours converted to minutes is 180 minutes. So we want the maximum number of songs. So we'll put all the songs that are 3 minutes long. So that's 50 times 3, and that would be 150 minutes. So we were able to squeeze in all of those. Now, of the 180 minutes, we've used up 150, so we still have 30 minutes remaining. So for the remaining 30 minutes, obviously the only songs we have left are the ones that are 5 minutes in length, so we'll put those in. But how many of those 5-minute songs can we squeeze in? Well, for 30 minutes, it would be 6. So 50 songs that were 3 minutes in length and 6 songs that are 5 minutes in length. So the total number of songs is 50 plus 6, which is 56. And therefore, number 11, the answer is C. In the table shown, a sequence starts with 2 in the top left corner moving across each row. Each box is filled with a number 3 greater than the number to its left. The leftmost number in each row is 3 greater than the greatest in the previous row. When all of the boxes are filled in, the value of x is. Here's x right down there. Now what's happening is you got 2 plus 3, then plus 3, and plus 3, and it kind of keeps on going, right? So every number is going to be 2 plus some multiple of 3, 3n, every number. So for example, this is n equals 1, n equals 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when n is 12, it will be 2 plus 3 times 12, and that is 2 plus 36. And that is how we got that 38. So just keep going. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 35 is what I have to put for n to get x. So 2 plus 3 times 35, and that's what x will be. So this is going to be 2 plus 105, and that is 107. So number 12, the answer is C. Philippa plays a game. She starts with a row of 15 squares and a coin on the center square. Philippa then rolls a die. If she rolls an even number, she moves the coin that many squares to the right. If she rolls an odd number, she moves the coin that many squares to the left. If the results of the 6 rolls were 1, 2, 3, 4, 5, 6, where would her coin be located? All right, so we've got 15 rows, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And the coin is in the middle. So the coin is right there. Okay, so now we got to start playing this game here. The first roll is a 1. Now the 1 is obviously odd. So if it's odd, she's going to move to the left. Okay. So 1 going this way, that way. So she ends up here after she rolls a 1. Then she rolls a 2, and the 2 is obviously even, so she's going to move 2 that way. So 1, 2, she ends up here. And then 3 is odd, so she moves 3 to the left. 1, 2, 3 ends up here after she rolls a 3. Then 4, which is even, so 4 spaces going right. 1, 2, 3, 4, so it ends up here after the 4. 5 going left, 1, 2, 3, 4, 5, so she's going to end up here after the 5. And then finally 6, which is even, so we go 6 places to the right. 1, 2, 3, 4, 5, 6. She will end up here after she rolls a 6. So which of the answer choices matches that spot? And that is 3 squares to the right of where she started. So number 13, the answer is E. A positive integer larger than 2 is called composite if it is not prime. What is the smallest prime number? That is the sum of 3 different composite numbers. Let's list some numbers here, 2, 3, 4, 5, 6, 7. And our answer choices are going up to 23. So I don't think we need to go farther than 23. Let's see what we get. Maybe we'll get it pretty quickly. First and foremost, we are only interested in composite numbers. So I can immediately cross off the primes. That's prime, 5 is prime, 7 is prime, 11, 13, 17, 19, and 23. All right. So from the remaining numbers, I've got to choose 3 different numbers and add them up to get a prime number. All right, let's see. Let's obviously start with the smallest ones because they want the smallest prime number. So 4, 6, and 8 are my smallest remaining composite numbers. 4 plus 6 plus 8 is 18, but 18 is not a prime. It's divisible by 2. It's an even number. Okay, no problem. Go back to the drawing board. Let's try 4, 6, and 9. 4 plus 6 plus 9 is 19, and 19 is a prime number. And there you go, that's it. So number 14, the answer is D. A list of 5 positive integers has all of the following properties. The only integer in the list that occurs more than once is 8. The median is 9, and the average is 10. What is the largest possible integer that could appear in the list? The median of a set of 5 positive integers is the middle integer when the set is arranged in increasing order. Okay, this is a question that the answer is controversial, and I'll explain why. So first of all, you've got A, B, C, D, and E, right? These are your 5 numbers. And they tell you that 8 occurs more than once. Okay, so that means 2 of the numbers are 8. Then they tell you that the median is 9. That means that the middle number is 9. And they even tell you that. It's very interesting how they even give you that. It's the middle. Emphasis on the word middle. So we are just boiled down to what is D and E. And that is where this piece of information comes in. They tell you that the average is 10. So that means if you add up these numbers, 8 plus 9 plus D plus E, then divide by 5, that's going to be 10. So adding this up, 8 plus 8 is 16. 16 plus 9 is 25. Plus D plus E is going to be 5 times 10 if you cross multiply. And therefore D plus E will be 25. So we have to choose D and E in such a way that we can maximize E. We want this to be as large as possible. And what I did was I chose 9 and 16. Okay? And therefore the largest is 16. Now you say, well, is this legitimate? And it absolutely is, because the middle integer is 9. So I chose 16, but in their answers, the University of Waterloo, they have chosen 15. So I went and I checked an online source. It's a website called Alcula. They have all kinds of calculators. You can calculate everything under the sun. And I checked an actual median calculator. And I typed in these numbers. And I said, okay, what's the median? And it spits out 9. So I don't see what I did wrong here. Unless I'm missing something. Unless all those years of education means that I don't know how to calculate the median, and neither does Alcula, which I highly doubt. What I think the University of Waterloo is doing with this question is saying that they want D, which is this number right here, to be greater than C. They don't say that in the question, but that is obviously how they're calculating it. And if that is the case, then the largest possible value can be only 15 because D has to be at least 10. You see what I mean? Because D plus E is 25. Well, the thing is, in math contests, there's always going to be one question here and there that you have a disagreement with, and that's okay. I think that happens. I just don't see why 16 is the incorrect answer. But in any case, according to them, the answer is A, and according to me, the answer is B. So I'll let you decide what's correct according to you. Rectangle PQRS is divided into 8 squares. As shown, the side length of each shaded square is 10. What is the length of the side of the largest square? So here's the largest square, and they want you to figure out the side length. All right, well, I'll call it X for now. And then these guys here, they tell me, are 10. So that's 10, that's 10, that's 10. And then the little ones I'll call Y. So Y, Y, like that. Okay, so we're going to be able to get a couple of relationships. The first one is that X plus Y is equal to 30, right? Because on this side, PS is X plus Y, and that's equivalent to QR, and QR is 30. So that's the first equation. The other equation we can get pretty quickly is that side is equivalent to this side. That means that X is equal to 4Y. Correct? Because this is 4Y. So there you go. You got two equations, two variables, and you can now solve. So here we go. So we have 4y plus y is equal to 30. That means 5y is equal to 30, and therefore y is equal to 6. And that means x is equal to 4 times y, and since y is 6, we have 4 times 6, so that is 24. And x represents the side of that square, so therefore number 16, the answer is B. 6 dice are stacked on the floor as shown. On each die, the 1 is opposite the 6, the 2 is opposite the 5, and the 3 is opposite the 4. What is the maximum possible sum of the numbers on the 21 visible faces? We have 6 die, and on each dice, there is 6 faces. So the total number of faces is 6 times 6, which is 36 faces. Now, we are told that they want us to maximize the sum on the 21 visible faces. So if there's 21 visible faces, then how many faces are not visible? Well, it will be 36 minus 21. So that'd be 15 faces that are not visible. And those are the faces that I want to concentrate on because I think it will be easier. So let's talk about them. The first are the ones at the very bottom like that. Those guys I will draw right here. Okay, the next one is this one, but that one has 2 faces, one on that cube and one on that cube, because both of those cubes touch. And then the next one, of course, is this, and again, same thing. We've got 2 faces, one on each cube. The next one is this one and this one, and in a very similar way, they have 2 faces touching each other. Then this one, which has 2 faces, and then finally this one, which has 2 faces there and there. And this should total 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it does. Now our task is to minimize the sum on that 15 faces. And because if we minimize that sum, then we can maximize this sum. All right, so here we go. So the minimum possible number I can put on a cube is 1. So I'll put the 1 here. That makes sense. That means that the face on the other side will be a 6. That maximizes the visible face. Okay, I hope that makes sense. And in a very similar way, this one right here, I can't put a 1, but I can put a 2 because the 1's already taken and it's the same cube. And if I put that, then it maximizes the visible face. Okay, so this is the strategy we're going through. Okay, now let's look at this guy over here, these guys. If I put here a 1, it maximizes the visible face. And then what about here and here, this guy and this guy? For those two, it actually doesn't really matter what you choose because the sum will always be the same. If I put 2 and 5, the sum is 7, right? And that's going to be the same as 3 and 4. If I put 3 and 4, the sum is 7 also. So this is fine. This is perfectly fine the way it is. Now let's talk about this guy. Well, it doesn't matter at all in this one because no matter what I put, the sums will always be the same. 1 always goes with 6. So 1 and 6 go here. 2 always goes with 5. If I didn't put those and I put 3 and 4, the result is the same since the sum is the same. So far so good. And then we just keep going like that. On this guy here, in a very similar way, I'll put a 1 here that maximizes my visible face. And then I can't put a 1 here because the 1's already taken on that cube, but I can put a 2, that's the next smallest number, and that maximizes my visible face by making it a 5. And then same thing here, same kind of story, I guess. I will put a 1 here that maximizes my visible face. And then these two guys, it doesn't really matter what you put, since the sum is always going to be the same. Whether you put 2 or 5 or 3 or 4, 3 and 4, the sum is always 7. And then we're down to our last one, and I'll maximize the visible face by putting a 1 on the face that is not visible. So there you go. This is the scenario. Now all we have to do is add all these up. So if we add these up, we're adding up these guys, like that, right? In any order, it doesn't really matter how you add them up. So that's going to be 6 plus 3 plus 7 plus 6 plus 2 plus 7 plus 6. And if you add this up, let's say 10. This is 37. All right, so 37 is what's going to be on the faces that are not visible. But what about the faces that are visible? Well, what's the total amount? The total amount, since we have 6 die, and each die has, if you add up the faces 1, 2, 3, 4, 5, 6, that totals 21. The total is 6 times 21. And that is 126. So if you have 126 as your total, and you have 37 on the faces that are not visible, if you subtract, you get the sum on the faces that are visible. And 126 minus 37 is 89. And that is the maximum sum that you can put on the 21 faces that are visible. So this question, the answer is C. A line with slope equal to 1 and a line with slope equal to 2 intersect at point 1,6 as shown. The area of PQR is. Well, they give you the intersection point is 1,6. So one line will have the equation y equals m, let's say m1x plus b. And the other line will have the equation, let's say y is equal to m2x plus b. Well, actually, this should be b1 and b2 because those are probably going to be different. Well, we can substitute in the slopes that they give you. The first slope is 1, so this just becomes x plus b1. The second slope they tell you is 2, so this just becomes 2x plus b2. Now the point 1,6 is on both lines, so I can substitute that into both equations to solve for b. So the first one becomes 6 is equal to 1 plus b1, and therefore b1 is equal to 5. So that equation is y is equal to x plus 5. The next one, if I substitute 1,6, I get 6 is equal to 2 times 1 plus b2, and therefore b2 is equal to 4. So that means that equation is y is equal to 2x plus 4. So to get the area, I just have to now figure out the coordinates of Q and R. That will give me my base. Because the area, of course, is going to be 1/2 base times height. And the base is this distance right here from Q to R. So I'll just put that in there, QR. And then the height, we already know, right? Because if you were to drop a perpendicular from, say, P down to the bottom, like this, that represents the height. And that distance, we know, that distance is just the y coordinate of P, which is 6. So the height is 6. All right, so to figure this out, we have to figure out where these lines cross the x-axis. So we just set y equal to 0. Setting y equal to 0 there, we get x equal to -5. So this is going to be -5 right here. Setting y equal to 0 on this guy gives me -4 is equal to 2x, so that means x is equal to negative 2. So that means this point right here is negative 2. So the distance from Q to R is going to be 3. So there you go. You have 1/2 times 3 times 6, and that looks like 9. So the area of PQR is 9, therefore number 18. The answer is B. How many integers n are there with the property that the product of the digits of n is 0, and n is between 5,000 and 6,000 inclusive? Well, n can be either 5,000 or 6,000, and then we have a whole bunch of possibilities in between. So I'll just put 1 and 1 just to show that that's how many numbers I have. The other possibility is that if you have a number of the form like this, where the 0 is the last digit, and this digit can be anything from 1 to 9. So I've got 9 possibilities here and 9 possibilities there. So 9 times 9, I've got 81 possible numbers of this form. Okay? And very similarly, a number could be of this form, where the 0 is here. Again, I got 9 possibilities, 81 numbers of that form. And in a very similar way, the number can be 50 blank blank, where again we have 9 possibilities for those two, again giving 81. And then there's 3 other scenarios. Another scenario is if you have 2 zeros. So for example, if the number looks like this, for this guy, you can put any digit from 1 to 9, so there's 9 possibilities there. The other type of number is if the 0 is there and there with any digit from 1 to 9 in that position. And again, 9 possible ways of making that number. And then finally is when you have 0, 0, and then blank, and again, it'll be 9 possible ways. So I think this covers it all if you add up these guys. So it'd be 1 plus 1 plus 3 times 81 plus 3 times 9. And that looks like 2 plus 243 plus 27. And that is equal to 272. So number 19, the answer is D. On Monday, Hank drove to work at an average speed of 70 kilometers an hour and arrived 1 minute late. On Tuesday, he left at the same time and took the same route. This time, he drove at an average speed of 75 kilometers an hour and arrived 1 minute early. How long is his route to work? So let X be the time that represents when he is exactly on time. And speed is equal to distance over time. That's the formula. And of course, any variation of this formula is valid, like distance over speed is equal to time. So on Monday, he drives, let's see here, distance, we don't know, that's what we're trying to figure out, over speed is 70, and he arrives 1 minute late, so X plus 1. But that 1 has to be 1 over 60 because we're talking in terms of hours and kilometers, because this 70 is kilometers per hour. So that's why I have to put 1 over 60. And then on the next day, Tuesday, it's the same, similar scenario, but this time his speed is 75, and he arrives 1 minute early, so X minus 1 over 60. So there we go. I got 2 equations, 2 variables. The first thing I can do, I guess, is subtract them. And if I do, I get the following. Let's see here. D over 70 minus D over 75. And on this side, that's going to be X plus 1 over 60 minus X plus 1 over 60. And that gives me 2 over 60 is equal to, and then I've got to subtract this. So 75D minus 70D over 70 times 75. And this gives me, if I isolate for D, I got 5D 2 over 60 times 75 times 70. And if you do the math, D comes out to be 35. So number 20, the answer is B.